Hello everyone. In this video we're going to be solving a fantastic exponential equation. Why do I call it fantastic? Because I really like this equation and I kind of came up with this idea, so it's homemade. But coming up with equations like this is not too hard. Just throw a couple numbers that are related and then make up exponents and you come up with an equation. But the results will be interesting and the graph will also be pretty interesting. So let's go ahead and solve this problem. Obviously, this could be considered an easy problem up until some point. I'll tell you why. 8, 4, and 2 are all powers of 2, so we can express all of them as powers of 2. Let's do it. 8 is 2 to the third power. I'm going to raise it to the power x cubed. And then 4 is 2 to the second power. And obviously, 2 is going to stay the same. Now, we can go ahead and multiply the exponents. 3 times x cubed is 3x cubed. And then I have 2 to the second here and 2 to the x squared. Dividing powers means you're going to subtract the exponents and have the same base. So we're going to get this from here. And as a result, we can safely say that the exponents are equal. So up until this point, everything looked fine, right? But now we got ourselves a cubic, which is not good, right? Maybe it's good. Let's see. So we've done similar problems before with cubics, and I'm hoping that you will recognize this from now on. What did I say? Check the coefficients, the sum of the coefficients. But wait a minute, what are you talking about? What coefficients? First, put everything on the same side. Make it a full cubic. I mean, as full as it can be. We're missing the x term, but that's okay. So, what is so special about this cubic is that if you check the sum of the coefficients, which is an idea that I really like, 3 minus 1 minus 2, you get 0. Yay! What does that mean? It means x equals 1 is the solution. But the story does not end here. Keep watching. What's the rest of the story? Well, x equals 1 is just one of the solutions. How about the other ones? Let's go ahead and find out all the solutions. And then at the end, we're going to look at a graph. And hopefully, that'll explain things. And we'll do a little bit of calculus towards the end. I just want to talk about limits because they're fun. Anyways, so we know now that x equals 1 is a solution. So we can kind of manipulate this equation. 3x cubed minus 3x squared. And we've done this before, remember? Plus 2x squared. So I kind of broke down the x squared, negative x squared, so that I can get an x minus 1 factor from here. You'll get used to it. The more you do it, the better. And now I need to follow up with a minus 2x, but I don't have a x term, so I have to follow up with a 2x to make it cancel. And then I have to end up with a minus 2, which concludes the process. But guess what? We have a factorable cubic. Now go ahead and take out 3x squared times x minus 1, 2x times x minus. See how it works out? That's what we were trying to do. And of course, if you want to do polynomial division or Horner's method, or what is the other one? Synthetic division. Such an interesting name. It's very synthetic. That's why I don't like it. So now, this is more organic. Okay. So now we're going to go ahead and take out x minus 1, and we will get 3x squared plus 2x plus 2. Awesome. Now, we got a linear equation, and we got a quadratic. So, it's solvable. Let's go ahead and solve the quadratic, because we already know the solution to the linear, right? Oh, come on. We knew x equals 1 is the solution all along. So, and obviously, I got to tell you something. You should probably guess that at the very beginning, because look at it. 8 divided by 4 is 2. Isn't that kind of obvious? I don't know. Maybe it is, maybe it's not. But x equals 1, you could probably see right away. So, what do? We solve the quadratic. We know x equals 1. And from here, let's see what we get. Negative b plus minus the square root of b squared, which is 4 minus 4ac. Uh-oh, that's not good because we're getting a negative discriminant. Minus 4 times 3 times 2, right? 4 times 3 times 2. That's 24. Uh-oh. That is going to give me negative 20. Okay, that's fine. Oh, and I'm supposed to multiply 3 by 2, so that's going to be a 6. So now x is going to become what? Negative 2. This is going to be negative 20. Remember, we talked about this, I think it was yesterday, right? Recently. We're going to write it as the square root of 20 times I on the outside, divided by 6. And obviously, square root of 20 can be simplified. We can write it as 2 root 5I. And this can be simplified a little bit. It can be written as negative 1 plus minus root 5I over 3. And that's going to be our non-real complex solutions. And x equals 1 is the other one. So what is going on here? We end up with a single real solution and two non-real solutions. And of course, this is significant in terms of graphing these two functions and looking at the intersection points. So that's going to be the next thing we're looking at. I want to show you the graph and how we can approach this problem through the graph. All right, let's go ahead and take a look at the graph of two things here. And I think the graphs are pretty interesting, especially the cubic one, because look at it. I mean, isn't that like a really interesting shape? So we have 8 to the power x to the power 3 divided by 4. Obviously, you can write this as a power of 2, like 2 to the power 3x cubed minus 2 as well. Just another way of writing it. And the blue graph, I think it's blue, right, is the parabolic or parabola looking graph. It's not a parabola, it's an exponential function, but it's symmetrical because of the x squared. If you had 2 to the x, it would just be going up, but this is kind of like a reflection of 2 to the x. Okay, because negative x values give us the same y values. Cool, so they seem to intersect at a single point, but how can I make sure that they really intersect at a single point? Well, we kind of verified with algebra, didn't we? Right? We got one real solution only, so that should be good enough. But graphically, how do we satisfy ourselves visually, right? So here's what we're going to do. We're going to look at the behavior of this cubic exponential function. I mean, first of all, its shape is really weird, right? It's acting real weird. Look at that. And it seems to be matching with the x-axis on the negative side. I mean, it's not completely overlapping, obviously, because of the zoom level. You see it as overlapping, but that's not the actual case. So let's talk about it from a limit calculus perspective. So here's what I'm talking about. If you take the limit as x approaches negative infinity of a to the power x to the power 3 divided by 4, you notice that as x approaches negative infinity, this approaches negative infinity, a to the power negative infinity approach 0. So the limit is going to be 0, which means x equals 0, y equals 0, which means the x-axis is a horizontal asymptote. That's why it behaves that way. So no other intersection points, okay? The graph is not going to jump like that. And on the positive side of things, if x approaches positive infinity, you're going to notice that our function is going to approach positive infinity real quickly, because look at this. It's like a super exponential, 8 to the power x to the power 3. And this purple graph is going to increase like crazy. It's going to shoot up when this guy is kind of taking its time. That's why they are not going to intersect again. They're going to get farther and farther away. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.